So let us discuss about Huffman coding. So let us take an example. Hello world. So hello world as an example. Now we are going to discuss here. So we should think that this is in letters, and the space also should be mentioned as in letters. Next, what we have to do is we have to identify the unique characteristics, and we have to write the characteristics line by line as per the slide. So we have an H, E, and L, O, R space, W, R, and T. Where L we should not write here because here is an L, we have already occurred L here, and O is also occurred here. So next we write what is the frequency of occurrence of the letters. So we have H and occurrence of 1, and E occurrence of 1, L occurrence of 3, and O occurrence of 2, and space occurrence of 1, and W occurrence of 1, and R occurrence of 1, and D is occurrence of 1. Next, what we'll have to do is, so next we'll be writing the um, in sign format, that is in 0 0 and 0 0 1, and this we call as in 2, and this we call it as in 3, and 0 0 0 1 1 is known as 3, and 4 is 100, and 5 is 1 0 0 1 0 1, and 6 is double 0 double 1 0, and 7 is triple 1. So now we have written in bit format. So now what we'll do is, what we'll do is, so we have 11 characteristics here and 3 bits, which is for that is okay. So that is 11 characteristics. So 1 2 3 4 5 6 7 8 9 10 11. So 11 into 3 we call it as 33 bits. That we mentioned here, and so there are 8 unique characters here, and we that mentioned in the bit format, that is 000 and 001 and 1010 and 011. So like this, as we discussed before. So this, here we have a concept that here. So more frequency, more frequently a symbol occurs, less bits to be used to represent it. More frequently a symbol occurs, less bits to be represented. So as we discussed this before, we have written the frequency of bits, and we have already mentioned that the frequency of bits, and so now what we'll do here is, after writing the frequency of bits, so now we'll do step one is remove top two items. So what is the top two items in the sense? What is the low frequency here? So we have an 0 point, let us say is 0.1, and now we have a 0.1. Here will notice on 0.1 and 0.1 also here. This is also 0.1 will also mark it as in 0.1, and this will mark it as in 0.2, and this will be marking it as in 0.3. There are three frequencies, and here also will be marking it as in 0.1. Okay, now we'll add all this. It is 1, 0.2, 0.3, 0.4, 0.5, 0.6. It's up to 0.6, and we have here 0.5. So we have an 11 unique characteristics. So we'll be having 1.1. So next, what we have to do is we should remove the first top two items here, and so that becomes the so that becomes the that becomes GH and E, like this. We'll be joining it and be taking it as that, and so we'll be joining it for 0.2. Here we'll be having 0.1. So we'll be adding that to itself. That's it. That is a common here. And next we'll go to the next slide. So as we discussed before, we have a we have thought that HE that becomes 0.2 now, and it becomes HE. So we have to write HE here. HE becomes 0.2. Then we should combine it. So frequency of HE and frequency of H plus E. So that we have to write here, and frequency of HE. So what is frequency of HE is frequency of H and frequency of E. So this becomes 0.2, and this is H and this is E, that we are both combined. Here it is 1 and here it is 1. So that becomes, and that becomes 2 here. So step 3 is remove original items and reinsert combined items. So we have here is we have a chi here, and that becomes 2, and where we should mention after the before the if we have three frequency, right? L has three frequencies, so that we have to mention before the highest frequency to the lowest frequency. So we have HE as a 2, so we should mention that before 3 or uh, mm, uh, the 2 or 3. So here we can see that is next. What are the two items that we have here is space and W we have here is. So next we'll be doing the space and W as a 2, and that becomes a 1, and this is 1, and this is 1. We'll be adding that actually to here. And the next for also the same for R and D. So that we're going to mention that is an R and D here, and so that it becomes 2 here, and by adding the R frequency and D frequency. So that becomes R&D, so that we can see the final transaction of the items here. So we have 0 O for 2 and HE is in 2 and minus I space and W2 and R&D is 2 and L is 3. Now next what we have to do is now we'll just come and put this O and HE. So now we'll be doing O and HE by adding O that is in 2 and HE that we have is in 2. That becomes 4 here and thus becomes the highest frequency, so that we have to write it in the last. And now let me do her space W and D here, and that becomes 4, and that also we should write here. Are you getting I think are you able to understand these things? So as we discussed before, this is one part and this is one part which will be adding. This is 2 and this is 2, and where this comes for 1, this frequency is 1 and frequency 1 and frequency 1. This becomes a frequency 4. Next, I'll be writing that here, and now I'll be writing finally I'll be doing here now what is it, I'll be developing a tree of Hoffman tree, so that as we discussed before, we have to write like this, um, and it is in the earliest highest frequency from the starting it is 3 and now it becomes the second highest frequency. So the first highest frequency is both OHM and space WRD, and so now I'll be combining it as a LOHE because these are the first two transactions. So I should go with the first two transactions itself. LOHE, LHE, and OH. So this is now it becomes the 7th frequency, and here is an L which is in the E frequency, and it is the 4th frequency where it is in the 2, and it is 2. It comes for 1. So next I'll be having this both LOHE for 7 and minus WRD for 4. So now this is the final tree of the Hoffman, which I'll be writing here. This is this will be doing it here, and WHRD and LOH. That is the thing we'll be adding here, and that is for final. Um, so WRD is for 4th frequency, and this is for 7th frequency. If we combine both are to get for the 11th frequency, the highest frequency is for 11, as we've seen before 11 characteristics, and now it becomes 11th frequency. Uh, so this is a part of all these before binary trees will be just combining to the final tree that we got as LOH, and here it is in 3 and here it is in 4, and this is for 7 and this is 2 and 2, and this is for 1 and 1. Here it is 1, 1 and 1, 1, and that is for 2, and here it's also for 2, and this is for 4. So that becomes 11 plus 4 equals to 7. After writing the after writing binary tree, then what we have to do Huffman tree. So what we have to do is so put left side 0 and right side 1 for all the transactions. So here we should get that to know as uh, here we are having a just a minute. I'll take my possible good looking color. So this is for this is left side and this is right side. So I mentioned here 1 and I mentioned here 0. And so this is left side. So I mentioned 0 here. I mentioned right side because of right side. I mentioned 1 here. So this is also for right side. I mentioned 1 here and left side 0 here. So for every transaction I should mention here 0 here and 1 here and 0 here and 1 here. Where left side, all the left sides are 0 and all the right sides are 1. So keep it in the mind and that should be noted by you. And this is the important if you do any, if you got any confusion, but it will be missing out. So after this, we mentioned here. So see that here, so we are mentioning right side, so right side, so 1 and left side, so 0. So that is, so now we'll find the length. Now we'll come to know that for each letter, let us find the length. So the length, which is the birth of the 2, we have here is only n. So it is 1 and 0. And so now let us find what is the last letter. Here is E and H, and for O also this is last letter. So let us now find the O. So 110 is for O. What else? We can go from the backward. Okay, so 110 or 011 is also fine. So we can write it either way. So 110 is also the good possible number. So see, so same have written down. This is possible way. Okay, this is the possible other way. So let us find for E. So E has all 4 frequencies. So length is 4. 1, 1, 1, 1. Okay, so let's mention here one. So for H 1, 1, 1, 0, 1, 1, 0. You should see the where it cuts the trees. So you should look at it carefully. If you if you're confused, then it goes for something else. And so you should not look back this side. If you only look this side, 1, 1, and where it goes here, 0. And then for R is 0, 1, 1. Yeah, yeah, it's for D. Sorry, so yeah, it's for D. Uh, Not for 0, it's for D. Sorry, before I was telling it. Sorry for my mistake. It's my mistake. So that it is D here, so it becomes 0, 1, 1. And for R, it is now 0, 1, 0, and W it becomes 0, 0, 1, and for space it's 0, 0. So that is here. And now let us write the frequencies here: 4, 4, 2, 2, 3, 3, 3, 3, 2, 3. So by adding all this, we'll be getting 32. 4 plus 4, 8, 10, 12, 15, 18, 21, 24, 27, 30, 32. That becomes 32. Size with the Huffman coding is 32. So what is an Huffman? So that's it on the Huffman coding. And thank you for watching this video.